We've seen so many different questions and concepts in this module, so I thought it would be good to walk you through a handful of them in this video right here. So feel free to skip around as much as you would like, or watch the whole thing if you think it'll help. The first example is to find the area under the standard normal curve to the left of z equals 2.4. So I would start this by drawing a normal curve, a standard normal curve, and labeling the mean 0 because the standard normal curve has a mean of 0. And z equals 2.4 would be on the right side. And so if I'm looking for the area to the left of z equals 2.4, that's all of this area in here. We're finding an area, so we know that the tool that we're going to use in the calculator will be normal CDF. And when we use normal CDF, it's going to prompt us for a lower bound. So I look at the far left or the far lowest value over here, and that's going all the way to the left, and so the lowest value would actually be negative 10 to the 99th power. We're going all the way up to an upper bound of 2.4, and this is standard normal, so I would enter 0 for the mean and 1 for the standard deviation. So second vars is where we get normal CDF, that's number 2, and we would enter negative 10 raised to the 99th, going up to 2.4, and then mean of 0 and standard deviation of 1, and we end up getting an answer of, it should be more than 50%. Oh, it's way more than 50%. Yeah, that makes sense because this is a couple standard deviations above 0. So yeah, 99.18% or just 0.9918. So that was an example from the beginning of this module. Let's take a look at number 2. According to the U.S. Energy Information Administration, the mean monthly household electric bill in the U.S. in 2007 was $99.70. Assume the amounts are normally distributed with standard deviation $20. Now, we're going to start paying close attention to things like this. They are coming right out in the problem and saying our population is normally distributed. So that's going to allow me to distinguish this question from a sample means question or a sample proportions question. Also, you can see that there's absolutely no sampling going on in this problem. So when they ask the question, what proportion of bills are between 85 and 140, we're saying, well, we identify that we have a normally distributed population, and the mean of that population is 9970. And now we can plot 85, it would be on this side, and we know that 140 is going to be on this side. And if we're looking for the proportion of bills between those values, then we're looking for this area in here. And we know, again, to find an area, to find a probability, we're going to use normal CDF. So I would say normal CDF, my lower bound is 85, upper bound is 140, mean is 9970, and the standard deviation they give us is 20. So if we go over here back into normal CDF, let's just enter that in. So 85 for the lower bound, 140 for the upper bound, a mean of 99.7, and a standard deviation of 20. And when we paste that in and evaluate, we get a value of 0.7469, and that's when we're going to 4 decimal places. So about 75% of the bills are between $85 and $140. Now in this question they ask for the 90th percentile of the electric bills, but we still know that the original population was approximately normal. So if the original population is approximately normal and we know that the mean is 9970, our 90th percentile is going to be the value, we don't know what it is, but we're going to look for it. We're going to find the value that is higher than 90% of all of the other values. And so we know the area to the left of our value of interest is our percentile is 0.9. So how do we find a percentile? How do we find a value here when we are given the area to the left? And that is the inverse norm tool in the calculator. So you would say inverse norm, enter your area to the left of, it should be 0.9 or 0.9, and then your mean and your standard deviation. And the mean and the standard deviation remain the same in this problem. So So let's enter into inverse norm an area to the left of 0.9 or 0.9, and then a mean of 9970 and a standard deviation of 20. We paste this in and we get a value that we were expecting to be greater than 9970. Again, that's why we sketched this out. We get a value of 125.33. So the 90th percentile of the electric bills is about $125. Okay, let's go down to example 3. In example 3, it says, how's your mileage? The EPA rates the mean highway gas mileage of the 2011 Ford Edge to be 27 miles per gallon. Assume the standard deviation is 3 miles per gallon. Okay, a rental car company buys 60 of these cars. What is the probability that the average mileage of the fleet, so they're talking about the 60 cars, is greater than 26.5 miles per gallon? So notice a couple things here. We are given a sample of 60 cars. And so if you have a sample, and in addition to that, they mention here that we're looking for the probability that the average mileage of the fleet is greater than 26.5. There's a sampling process and there's a mean involved. And so it doesn't use the words sample mean, but it uses the words average, and we can see that they're talking about the average of the sample. So we have to infer that this is going to be a problem involving the distribution of sample means. Now we know that a distribution of sample means is approximately normal as long as our sample size is at least 30, which we can check that box. So let's plot the x-bar distribution real quickly here, and we'll label the mean of this distribution to be exactly what the mean of the population is. And we were told the mean of the population. The EPA rated the mean gas mileage of the Ford Edge to be 27 miles per gallon. So that 27 is equal to our mu. So we'll say mu is equal to 27. And when they give us in this problem that the standard deviation is 3 miles per gallon, that is referencing the population standard deviation. So when they say 3 miles per gallon, that's our sigma. So if sigma is equal to 3, then in the distribution of sample means, our standard deviation is going to be a little bit different. So let's set this up. It says, what's the probability the average mileage of the fleet is greater than 26.5? Well, 26.5 would be on this side. So let's label that 26.5. So I'm shading this area underneath that distribution of sample means. This would be another normal CDF, and our lower bound is 26.5. The upper bound is 10 to the 99th. Our mean is 27, and the standard deviation is not 3. It's 3 divided by the square root of our sample size. We recall from earlier that the standard deviation of the distribution of sample means is sigma divided by the root of n. So this is one of the biggest mistakes that students make in this course, is they forget that they really have to pay attention to what distribution are we working with, and if it is a distribution of sample means, then we have to account for the standard deviation properly. So going into the calculator, we say second vars, and go to number 2, normal CDF, so 26.5, upper bound of 10 to the 99th. Whoops, I put in 26.4, let me fix that, 26.5, up to 10 to the 99 with a mean of 27, and a standard deviation of 3 divided by the square root of 60. Make sure you put that division symbol in. A lot of times I see students say 3 times the square root of 60, but it's 3 divided by the square root of 60. And let's paste, and we get an answer of 0.9016. So we've got about a 90% chance that the sample mean is greater than 26.5. Now, I will continue with these next couple of examples in the very next video.